Okay, recording is on now. So let's start today's session. Before I start, let's review that what we learned in our last class. We already we have already started a new topics. It's called the process and thread. And in our last class, we talk about some concept like what is the kernel and what is the user mode and kernel mode of operations. And then context switching and mode switching. Context switching means when switch between one process to another process, and mode switching means switch between one mode to another mode, means that user mode to kernel mode. Okay, and also we know the kernel is a part of your operating system. It is not exactly the whole operating system. It is part of operating system that contains the important or frequently used functionalities of a operating system. Okay, of an operating system. So then we talk about the state of a process, and we saw one state diagram, and in this diagram we also saw that several state can hold a process. So one is for new state, it can be ready state, running state, we know about the IO state, and terminated state when a process completes its execution. It's known as the terminated state, you know. And then suspended ready state and suspended IO state means when higher priority process comes into the RAM, then one ready process or IO process needs to write back to the disk. It is actually known as suspended ready as well as the suspended IO state when a process backs to disk during the IO time, during IO state. Okay, and okay, that's states of process. We saw one diagram in our last class. So today we talk about the process again. Continue our discussion with the process, and after completing our process stuff, then we'll move to the thread. Okay. Yeah, in this module name is process and thread. So now we are talking about the process. Okay, process only. So today we'll talk about the process control block. Okay, I have to draw this process control block. So let me switch back to my iPad. Let me turn off my video first, and then let me share my screen. Okay. Share my screen from my pad. Share, and then I'll share the whiteboard. Okay, whiteboard. So you can see my screen. Oh, now let's see what is, as I mentioned, what is the process control block. Process, we talk about the process control block. Okay, in short, it is known as PCB. Okay, PCB. You may often hear the PCB as well. Means the process control block. Before we start the process control block, let's talk about two concepts like active entity and passive entity. What is the main when you create a process? Let's say in your disk there are several programs will be actually inside in your disk or software. These are reside inside your disk, and then when you click, then actually it's create a copy, and it is now in execution phase. We call it, this is the process. Okay, process. So this process is also known as the active entity. Okay, active entity. Active entity. Entity. Okay, and the program actually that's inside your disk. Actually, when you save any file or any programs or any software inside your disk, actually there could be several programs, several programs inside your disk. So these programs, when actually it is inside the disk but not in a running phase, or it is not a process, this this is also referred as the passive entity. So here I write this passive entity. Okay, these are two things. Okay, active entity, passive entity. Also from the process, actually it is in running phase, so it is obviously it should be active, and then some program it is not in running phase. When it is not in running phase, it should be passive. Okay, from this definition you can also understand that it should be the process should be the active entity, and when it is a program phase, then it is a passive entity. Okay, this is the two definition or concept. Now let's move into the process control block. What actually a process contains. So far we saw that here actually we create some process and it's back sent to the, and your long-term scheduler, it's scheduled inside the RAM. Well, let's see this thing. This is a process. Okay, let's see what actually what is the items or ingredients inside the process. Today we'll talk about that things. Okay, a process control block. A process can contain several items or several ingredients. Like the process, first it contains the text. Not only text, actually text is nothing but your program or code. Okay, it's code. First is text or code, and your code part, or we can say this code part. If you write a one program, process is this is the program part, or you can say program part, and next is data part. A process can contain, this is a one process. Okay, one process, PCB, process control block. So one process can contain this all. If where one process should have this all items. Like first is it should have the text or programs. Text or text is nothing but the program or its code. Okay, you know that every software is nothing but a program. The program is in here, and next is data. We'll talk about the what is the data, and then another part is heap, and then another part is stack. Okay, stack. So it can be grow this way, or heap can be also grow this way. This is kind of, we can say this is the one of the free space. Okay, so these are the items that a process can hold, or this is known as the process control block, PCB. It contains the programs, data, heap, and then stack. Okay, the text part is nothing but your programs or code, and data part actually it contains what it contains. It contains the, you know that when you define a variable in a program, that's static or global variables. Global variables in your programs. These static and global variables actually inside this data part, always be inside this data part. Okay, so from here you can see that if you define a global variable, it always be inside in data part of your process control block. Okay, and the static also same as it should be always inside your data block of a process. And next is the heap. heap. Okay, okay, heap, and then we'll talk about the stack. Okay, let's see the heap. What's the heap block contents? When you need, when your programs actually need some dynamic memory allocations, that time this memory allocation actually these memory allocations take place inside the heap. Okay, the dynamic memory allocations allocates the memory within the heap space. Okay, within the heap space. What is the dynamic memory allocations? You already know about this dynamic memory allocations. If you're familiar with the C programs, you may use the pointer like, and then you use the malloc and calloc sometimes. And also, if you have familiar with the C++ programs, you know that you define this integer, let's say integer pointer, and then you make this new int. This is dynamic memory allocations. Okay, new ints, if you array kind of like this, you can define this way. Okay, similarly, by using this new keyword, you dynamically memory allocates the memory. So where it should be allocates, when you run your programs, this memory should allocates. Also, it should store inside your process. So where from where it takes this take this space. This dynamic memory allocation always take this space from your heap, from the heap space. Okay, always inside this heap block. Okay, and next step is the stack. Stack is nothing but it calls the function call. Okay, it's called if your programs it's contain a function. Let's say you write one function and some function in here. You call this function, and then inside this function you may call another function as well. So f2 is in here, f2 is in here body. So this stack function call, the first is first it will store the function. Let's say first is called this f1, and then f2, all function call actually tracked by inside the stack. Okay, stack is first in first out. So this is first. So if you declare here is one function call, and inside this function call you make the inside this function there is another function calls. So from your programming perspective, this function should be execute first. So this one should be execute first. So first in first out. That one actually comes out then first, and then it will return back in here and complete this function, and this function then finally comes actually removed from the stack. So any also in stack contains the functions. All if you define any variable inside local variable inside the functions, it also it also allocates inside the stack space. This is space. Okay, any local variables, global variables in here in data in this space will take place in this space. But local variable, if you define any local variable for a function, it will actually store inside the stack. Okay, inside this stack. And also here you also see that this is the free space. This is also free space. So I make one down arrow and one up arrow. This is heap. So from here, this free space actually we don't know that heap can take sometimes in some programs. If you allocate the more dynamic memory, so it may take this more memory from this free space. So it may grow up, and then if any process actually needs some function call, then also it may take more space from this free block, from this block. So it can actually grow, or it can grow depending on your programs. Okay, whether stack will grow right now, or then or a heap will grow right now. Okay, it depends on the programs. So any if your function call is higher than this heap, then your stack will take the more more storage than the heap. And heap, if you in some programs you actually use lots of dynamic memory allocations or lots of pointers, then your heap will take the more space than the stack. Okay, these are the actually part of one process. Okay, these are the different parts for one process. When we create a process and then it moves to the RAM, actually it's nothing but contains all of these things. Okay, it has a stack, it has heap, data, and program codes. Okay, all are this all are actually refer as the process control block. Okay, any questions regarding process control block? Okay, so next is our no question. So next move forward our next topic. Next topic is the process attributes. This is process control blocks. Let's say what are the attributes for a particular process. Several attributes. A process can have some attributes. Let's see what are the attributes for a particular process. Let's say a process should have one is called the process ID. Okay, process ID. Okay, you know that in process control block it manages this ID. Okay, process, of course, a process should have a unique process ID. By using this process ID, your OS can uniquely identify a process, a particular process. When you create a process, your OS will assign an ID for a newly created process. Okay, it should be always unique. And then another thing is that the program counters. These are the process attributes. Let me write in here. These are called, all are the process attributes. Okay, process attributes. So first one is the process ID and then program counters. Program counters. So what is the program counters? The program counters tracks the next instruction executed by the CPU. So if let's say you have 1,000 lines of code, okay, thousands line of code. So it first execute, your CPU first execute this line and these lines and these lines, line by line it will execute. So program counter is nothing but track this which line will be execute next. Okay, which line will execute next. If you are right now you are in here, then your program counter will know that you needs to execute this line next. Okay, this is the purpose of program counters. And then another attribute is process state. Process state. Oh, you know about this process state. It can be in different. It can be running state. It can be IO mode. It can waiting state, or it can be suspend ready, suspend IO. This kind of stuff. Okay, process state. This is one of the attribute of a particular process. And then a process also have another attribute is general purpose register. General purpose register. Okay, when your programs is executed by the CPU, then actually in your CPUs different kinds of use the different types of registers to store the value to execute the instruction. One instruction, it should store some value inside a different kind of many register, different types of register. It's used for storing the value to execute a process. Okay, so these are the process. These are the register value this register value actually should be stored or saved when a process is forcefully preempted by the CPU. What does it mean? General purpose register, it should be this is one of the process attributes. So when your CPU run a process, from the memory, let's say this is the memory or RAM. In here, let's say currently is P1 is running in by the CPU, and then a new process comes inside the RAM. It's P2, and its priority is higher than, and P2's priority higher than P1. What your OS will do right now? Right now, your OS will schedule the CPU for process P2. But let's say your P1 is now was running. So it was running till line number 50. Your program was line number 50. It was running, and then P2 comes to the RAM, and its priority is higher. So your CPU preempted the stop or preempted. We use this preempted, this term preempted. Preempt the process P1 and start to execute the process P2, because P2's priority is higher. So P1 is executes till line number 50. Also, this line in this state, when it's execute for line number 50, there are several registers. Also, there are several register value as well. This is CS, AX, BX, this kind of register. Also, here is kind of let's say here is value like 50, 60, and here is also let's say 100. This kind of value it's needed in this stage. This P1 when it's P1 executes till 50 number line, this is the value for AXBX, this register value to execute for the next line. Okay, next line. So and currently P1 is comes to the actually is scheduled for the P2 is scheduled for running by the CPU. So in that case, you know that these are the all general purpose register for any process. Okay, for any process. When P2 actually is run by the CPU, then P2 will also use this general purpose register as well. Okay, and let's see, after some times P1 completes its execution, and then it will be terminated by your operating system from RAM, because it completes its execution. So P2 is now terminated, and then P1 will get again actually chance to take the start the execution. Okay, then now P2 is completed its execution. Now P1 will be again is scheduled to executes by the CPU to complete its execution. Okay, so previously P1 completes till line number 50, and this was the value that time. Okay, and by this time P2 also executes. Okay, P2 executes, that time this value is changed by the P2. So before actually preempted by this process P1, instead of this process P1, you have to track this value, register value somewhere, because when actually P1 will be scheduled next, that time you need this value, because when P1 is scheduled, it's completely line number till 30. It won't actually execute from this beginning again. So it will start from this line number 51. It's completely till it executes till 50, line number 50. Then it will execute from the line number 51, not from the 0. So in line number 51, the all register value you should store somewhere. Okay, you should store somewhere. Okay, this is the general purpose register register attributes for a process. Okay, you should store this value somewhere. So where it is stored? It is stored in a RAM somewhere in OS space. Okay, OS space. This value is stored somewhere inside the RAM in OS space. So when P1 is P1 actually again is scheduled for execution, then P1 process, and then this saved value also loaded inside the register. Okay, inside this register, what is the stored value for this process during during the execution time. Okay, then it start execution. Okay, these are the actually purpose of general purpose register attributes for a process. Okay, any questions for general purpose register? Okay, so you may ask me any one question like that your long-term scheduler, actually your long-term your short-term scheduler is schedule the function, schedule the actually process from RAM to CPU. So which function actually store this value saved value from RAM to register? Which function does it sorry, is it short-term scheduler? Actually, no. There is another function is called the in OS. There is another function is called the dispatcher. Dispatch. Dispatch. Okay, dispatch. So dispatch function actually, it is also an operating system function. These functions load the saved value from RAM to register. And short-term scheduler, actually short-term scheduler load the process, actually schedule the process from RAM to CPU. And when it's actually scheduled from RAM to CPU, this time also dispatch function also called by the OS if there is any saved data for this particular process or not. If it is saved data is actually available for this process, this data is loaded by this function. So by using this short-term scheduler and dispatch function, essentially actually used to execute a process. Okay, these two functions is actually are used to execute a particular process. One is short-term scheduler, another function is called the dispatch function. Okay. Okay. So these are the general purpose registers. For details about the general purpose register, let's see what is the another is called. What is another attributes? Let's say next attribute is priority. So priority, you know about this priority. Priority actually nothing but it refers the relative importance and compared to others processes running on the system. Okay, if priority is high for this process, it will schedule, and then if it is low, then it will printed by the CPU and kind of like this. This is another attribute for a process priority, and another attributes could be the list of open files. List of open files. So this is nothing but currently opens file for a particular process. How many files? You know that when you run a process, when you run a program, you can read a file or write a file. But when you use the any software like MS Word software, you can open different files. Okay, so list of open files is nothing but how many files is currently open by this process. So when you save, when your process is printed by the CPU, this thing also saved inside the RAM as well. Okay, current state that how many file was open open at that states of a process. Okay, these things also keep track by your operating system as well. Okay, and another thing is that similar things is kind of list of open device, list of open devices. So your process may needs to go for some printing, needs to do some printing job or some, let's say, read from data from HDD as well, read from data from USB drive. So it's open. Also, it also read the data from keyboards. At that state, if process is printed, so this type of list should be stored somewhere in case the currently runs process is printed by the CPU. Okay, so when it's again it's scheduled for execution, so you need these information: how many file was open and how many device was opened actually last time the when the process was executing. Okay, next is the protection. What is the protection is sorry, number 8. Okay, protection attributes is nothing but, so when actually you create a process in here, P1 P2, so P1 cannot directly access the data from P2. Also, P2 cannot directly access the data from P1. So this is kind of the protections. If two process in our future class, we will see if two process actually use the same data in same location, there is kind of problems. If it's directly access the data. So this is the actually refer as this protections. One process, this is the process, this is the actually PCB or process control block for P2. This is the process control block for P1. So from this control block, P1 cannot directly access the data from P2. Also, P2 cannot directly access the data from P1. So this is actually example of the protection attributes of a process. Okay, these are all for the process attributes. Okay, next talk about some scheduler. We already know about different kind of scheduler, like long term, so long term scheduler, and then second is we know about the short term scheduler. Okay, right here. And then another is medium term scheduler. You may not hear about this medium term scheduler, so take some note in here. You may hear about only the long term and short term. Also, today we'll talk about what is the medium term scheduler as well. Okay. So before I go, let's say this is the CPU and this is the memory, or here is your disk. Okay, here is some process in here you already created. This is the process, let's say, and then when you make this process, create this process, so how many process will be scheduled in here? When you create the new process, how many process will be scheduled in here? That things was decided by the long-term scheduler. Okay, long-term scheduler. So when you create the new process, a new process created, then actually when you create the new process, this new process, how many process will be resided inside this RAM? This thing is done by your long-term scheduler. And short-term scheduler, that which process will will currently will be execute next. Okay, this thing is decided by the short-term scheduler from this RAM to CPU. This thing is done by the short-term scheduler. And next is medium-term scheduler, means that when you create a new process in here, also there is no space. There is no space inside the memory. But you create a one process, means that let's say it's P4, and its priority is higher than all of this process. All of this is for, let's say here created new process P5, and its priority is higher than all of this process. In that case, one process actually needs to write back to the disks and give the space for the process P5. Actually, this intermediate things is done by the medium term scheduler. Okay. Scheduler. So long-term scheduler is nothing but how many processes will be at the beginning, how many processes will be there inside this RAM. This thing is tracked. And when there is a no space for a process, a new priority process is created, that time one process needs to be write back to the disks. This thing is done by the medium-term scheduler. Okay. So any questions so far? Process attributes and process control block and different scheduler. Okay, so let's move to our next item. Okay, so in next we'll talk about some CPU scheduling algorithms. But before we start the CPU scheduling algorithms, we need to know some other time related terms for a process. Let's say then it will be very easy to understand when actually we talk about the CPU scheduling algorithms. Okay, some time related terms we'll talk about now. We'll talk about some time related terms for a particular process. Okay, you need to know about this term. Let's say first is this is time related terms to a process. Okay, to a process. Okay, so time related term to a process. Let's say first one is the arrival time. Arrival time. Arrival time. Arrival time is nothing but from this name you can also identify things. From here is your process. So at that time when it's arrived, this process arrives to the RAM or comes to the RAM. At the point of time when the process arrives into the RAM. Okay, this is the arrival time. And another term is called the burst time or execution time. Burst time or execution time is same thing. Is total time for executing a process. So total times to need execute this process by the CPU. Okay, this is called the burst time or execution time. Okay, these are the same terms, like the burst time or execution time. Okay, total times. Let's say process P1, it needs completes its to complete its execution. It needs, let's say, 10 nanosecond. So 10 nanosecond is its burst time or execution time. Okay, and three number third point is the completion time. It is nothing but at the point of time when a process completes its execution. Okay, you know that when a process comes in here, it is not comes in P1 is arrival to the RAM or inside the RAM, and its execution time is 10 nanoseconds. So its completion time should be the 10 nanosecond. It is not true. Okay, it is not true. You know that there could be some another process P2, P3, P4. Okay, even though its execution time is 10 nanosecond, after 5 nanosecond it may preempted by the CPU, and then it's also here it needs to wait in here, and P2 will be executed by the CPU. So completion time is not always, it's actually not always the burst time or execution time. Okay, process may needs to wait, and also in here also also it needs to wait in to get the slot from for a CPU. Okay, so completion time could be always could be is greater than or equal the burst time. Okay, next is uh, number 4 is the turn around time. Turn around time. Okay, turn around time is nothing but the equal completion time minus arrival time. Okay, this is the turnaround time. Okay, turnaround time is nothing but the completion time minus the arrival time at the point when the process comes into the RAM, and then when the process actually comes out or terminated from this RAM. Okay, this is the difference between this is turnaround time. Also from here you can see that how long actually a process inside the memory of RAM. This is also nothing but a turnaround time. When it comes in first time, it comes into inside the RAM, and then when it completes its execution. So how long it inside the RAM, it's referred as the turnaround time. Okay, 5 is we can say number 5 is waiting time. Waiting time is nothing but the process may preempted, you know, that process may preempted by or forcefully stopped by the CPU due to higher priority process. Let's say process P1 is currently executing by the CPU, and it takes 10 nanoseconds to complete its execution. But after 5 nanosecond, higher priority process comes inside the RAM, and process P1 P1 is preempted by the CPU or stop execution by the CPU, and is scheduled for the process P2. So currently P1 is inside the RAM, but it is now in waiting state. Okay, this is called the waiting time. The process may preempted due to the higher priority of process, so it needs to execute. It needs to wait and again to complete its execution. Okay, this is the waiting time. And number 6 is response time. Response time. What is the response time? In response time is waiting time of a process until it gets the CPU for first time. Okay, let's say it's one process P4. P4 arrives to the RAM at let's say at second let's say in time 10 nanosecond. Okay, sorry, let's say it's 20 nanosecond. When clock is in 20 nanosecond, this processing arrives inside the RAM, so it is now in ready state. And here process P2, P1, P2, and P3 is currently in executing or switching to each other and completes its execution. And then let's say after 25 30 nanosecond, it gets the first CPU. So its response time is 30 nanosecond actually. When it's even though it's arriving in 20 nanosecond, but first time it gets the actually it gets the CPU first time. It gets the CPU first time. Okay. This is called the response time. When a process gets the CPU for first time. Okay. This is the response time. And another is the IO time. IO time. IO time is nothing but you know about this amount of time to process performing the IO. A process needs to be, so from here you can see that a process can be after arriving, a process can be you know that burst time, it can be execute, or a completion time completes the execution, or it can be wait, or it can be wait. Wait also is kind of one of the first time response time. It needs to wait here. Let's see, it needs to wait for 10 nanosecond. Okay, it's waiting time as well as its IO time. So another equation for turnaround time is for turnaround time is equal to, we can say, burst time plus waiting time plus IO time. Okay, IO time. Yeah, this is IO time. So all three is equal to the total execution total turnaround time for a particular process, means the completion time minus arrival time. So also we can write this equation by this using this formula as well. Okay, it is equal to burst time means the execution time, waiting time plus total IO time. Okay, or it can be completion time minus arrival time, same thing. Okay, so these are the different time related terms for a particular process. So next, do you have any questions? Okay, so if no, let's move our next topic. So far we talk about different terms as well as that how a process can execute by the CPU. CPU sometimes printed a particular process. Also, we talk about the different scheduler. Also, we know about the different process attributes and process control blocks. Let's see the what is the, let me clear, what is the different CPU scheduling algorithms. In our previous lecture, we talk about different memory allocation algorithms. Let's say first in, next in, first in, next fit, first fit, next fit, also best fit, and then also what's called frame allocation algorithms. Okay, today in this section we'll talk about some CPU scheduling algorithms. Previously we saw that memory is how to actually allocate the process. AdvOS allocates the memory for a particular process. Okay, by using best fit, worst fit, next fit algorithms. It can also paging methods. We saw that this kind of algorithms. Now in this section we will talk about the CPU scheduling algorithm. Means that your short term how operating systems short-term scheduler functions allocates the actually CPU for a particular process, schedule a CPU for a particular process. So there should be some algorithms we'll discuss actually in this section. Okay, let's see CPU scheduling algorithms. Okay, CPU scheduling algorithms. Mainly, we talk about the schedule here. Let's say this is your CPU and this is your computer's memory. Here is OS. Also, here is different process. Or you can say this is PCB or process control block. And P3, let's say P4. Okay. This is the different processes. Now, your short-term schedule function of your operating systems actually schedule a process from RAM or memory to CPU. This of course there are several algorithms inside the short-term scheduler. We'll learn this type of algorithms. Okay, we'll learn this what kind of algorithms a short-term scheduler can apply to execute a particular process. Okay, so in broadly the CPU scheduling algorithms we can divide it into two types. One is preempted scheduling algorithms. Preemptive scheduling. This is very important topic for your next not first midterm. It is from your for your the second midterm. Okay, preemptive scheduling algorithms, and one is non-preemptive scheduling. Scheduling. Sorry, let me clear it a little bit. Non-preemptive scheduling algorithms. Okay, two types of algorithms: preemptive scheduling algorithms and non-preemptive scheduling algorithms. So what does it means? You already know about this preemptive. Preemptive means that the CPU actually forcefully stop a process when the new process or higher priority process comes into the RAM. Okay, this is the preemptive scheduling algorithms. The CPU can preempt a process. Preempt means that CPU forcefully stop a process when a higher priority process, when a higher priority, don't forget about the priority, first priority, higher priority process comes into the RAM. Okay, when higher priority process comes into the RAM, so CPU will preempt it, forcefully stop this current execution process, and your OS makes a schedule for the higher priority process. Okay, so this is the preemptive scheduling algorithms, and next one is the non-preemptive scheduling algorithms. So what is the non-preemptive scheduling algorithms? The CPU cannot preempt, or CPU cannot actually forcefully CPU cannot preempt a process from its running state, even if a higher priority process is available. Means that let's say here is 4 process we see here inside the RAM. We said that there are 4 process. So let's see, P1 is now currently executed by the CPU. P1 inside the CPU is now currently is executing the process P1, and then P2, P3, P4 all are higher priority than the P1. Okay, P1. In case of non-preemptive scheduling algorithms, the CPU cannot preempt the process from its running state. Means that P1 is currently running, so it should be complete fast, and then your OS will schedule a process which has the higher priority. Okay, once it's actually a process runs inside the CPU cannot preempt it. CPU cannot stop it, even though higher priority process is available inside the RAM. This is the non-preemptive scheduling algorithms. Okay, from this naming you can understand why it is non-preemptive, why it is preemptive. Preemptive means that your CPU can stop this process when from its running state, and of course when a higher priority process comes inside the RAM, when it is inside the RAM, okay, forcefully stop. In case of preemptive scheduling. For non-preemptive scheduling, when a process inside the RAM, even though here is higher priority process is available, when a process is executing by the CPU, but by this time higher priority process comes inside the RAM, your CPU cannot preempt this process because it is now in running state until it completes its execution. So this is the non-preemptive. Your CPU cannot preempt a process even though higher priority process is available inside the RAM. Okay, from its running state, it cannot preempt it. So this is the non-preemptive scheduling algorithms. So there are several types of non-preemptive as well as the preemptive scheduling algorithms. We will learn one by one. One algorithms is called the is called. Let me clear some here. One algorithm is called the shortest job first. Okay, shortest job first, SJF, shortest job first scheduling algorithm. Okay, shortest job first, or SGF, is mainly known as the SGF scheduling algorithms. It is a example of non-preemptive scheduling algorithms. Okay, this is a one kind of non-preemptive scheduling algorithms. Okay, means that when a process in running state, CPU cannot preempt it, CPU cannot stop it, even though higher priority process is available inside the RAM. Okay, this is the one of the non-preemptive scheduling algorithms. It is shortest job first scheduling algorithms. So today we can stop here because it is a lengthy algorithms, shortest job first scheduling algorithms. We will learn these algorithms details in our next class. So before we go, do you have any questions or comment? Today's class or for your exams or anything? If no, I already mentioned in next Thursday is your first exam, so please be prepared for this exam. You will get whole day to take this exam, but please don't wait till I think I scheduled for 1 hour exam, 30 question, and each question you will get the 2 minutes. So it is 1 hour exam. So don't start at 11 p.m. at Thursday. Please take this exam before. Okay, so if you have any questions or anything related to our previous lecture, if you don't understand or if you need to any clarification for any topics, please email me anytime. I'll be available. No worries. Okay, thank you. Have a good evening and see you next class.